it's a laboratory experiment involving machines called interferometers. Mm-hmm. And it has to do with measuring fluctuations in lengths that you would expect to see on the basis of combining quantum mechanics with gravity if you believe in these ideas relating the shape of space to the amount of quantum information in it. My name is Thomas Banks. I'm a professor at Rutgers University in the state of New Jersey in the United States. I live in New York City, commute from there to New Jersey several days a week, and I've worked there since 1989. I used to also work part-time in California at the University of California, Santa Cruz. Okay. I work in theoretical high-energy physics. Lately, I've concentrated mostly on studying the theory of quantum gravity. This is a very esoteric field. We have very little experimental information about this, but we've had a lot of theoretical ideas coming from the field called string theory, which gave us a lot of insight and input into it. That lasted for about 15 or 20 years. And then for the past 20 years or so, people have been going off in different directions. I have chosen my own set of directions, and I think are more correct than the directions other people have gone in, and they're very much connected with various ideas in other branches of physics.
What did you come to do here in Bariloche, and what do you think about the Instituto Balseiro?
Okay, so this is a very well-known institute outside. I know several of the researchers here. I know their work very, very well. I know Gonzalo well because he was a student at Rutgers, but I also know his work since then. I know Horacio Cassini and Marina Huerta very well from their work. I've seen them speak as well, so it's a very prestigious place from the point of view of outsiders. I think most people in my field would consider this to be probably the leading institution in Argentina, at least in our field. And so when I thought about coming to South America, this was one of the places that I really wanted to come and visit, talk to people.
You came within the program Maldacena, Programa Maldacena, right?
Yes, that's correct.
Okay, and did you give classes, seminars, talks?
I'm going to be giving 2 lectures here, one today and one on Thursday.
Excellent. Would you like to tell us more about what ideas are you developing about quantum gravity, or
yes.
at least the main idea?
Yeah, the main ideas have to do with the relationship between the geometry of space, the amount of volume of space, or it's actually area enclosing the volume, and the amount of quantum information that's enclosed in that volume. So this is the relationship between space, time, and quantum mechanics. And we had very specific ideas about this, which are based really on some older ideas by a professor named Jacobson from the University of Maryland. And it relates to the field of hydrodynamics, which is part of a completely different branch of physics called condensed matter physics. And we think that there's a lot of development that can be done in this direction. It's very, very difficult for anyone to convince anybody else of what they're thinking about in these fields because we have as I said, very little experimental data. And one of the reasons I recently got a little bit excited is because one of my collaborators, Catherine Zurich from the California Institute of Technology, has proposed a possible experiment for actually testing some of these ideas. And they're building a machine at Caltech that might actually test some of these ideas. So that's an exciting new development.
When is going to be ready? Or when are you going to start?
This depends on funding.
Mm-hmm.
And so it's at least 5, maybe 10 years down the line.
Is related that experiment to black holes?
No.
Nothing?
No.
Nothing at all?
No, it's a laboratory experiment involving machines called interferometers.
Mm-hmm.
And it has to do with measuring fluctuations in lengths that you would expect to see on the basis of combining quantum mechanics with gravity if you believe in these ideas relating the shape of space to the amount of quantum information in it.
So we are searching for a how do you call la teoría del todo? A unified theory?
Well, yes, that was part of the dream of string theory. We're very far away from that, and nothing that I'm doing right now speaks to that aspect of things at all. It's much more, it's on a much more primitive level than that.
What would you tell young students of physics that are interested on studying the same field than you? What would you tell them? What advice would you give them?
So what I would actually say to young students right now is that there are fields that are more fruitful to go into right now. The fields of quantum information, having to do with the possibility of developing quantum computers, and also various aspects of the physics of condensed matter. There are many new states of ordinary matter that have been discovered in the past 20 or 30 years that we don't understand. And there's very fascinating physics associated with those. And there's much more, because there's much more experimental data, there's much more chance of making a lot of progress in those directions. And there are connections between that and all of these ideas about quantum gravity. So I would advise young people to go, even if they're interested in quantum gravity, to concentrate on these other fields, learn what there is to know about these other fields, try to contribute in those fields, and keep in mind how those things can be applied to thinking about quantum gravity, if that's where their interests lie.
What do you think the theoretical physics, what are the main challenges nowadays of it?
Well, I think for the branch of physics that I work in, the biggest challenge, and this has been true for a long time, has been that the experiments are so hard. The main experimental tool has been particle physics, the construction of these large accelerator machines like the one in Geneva. These require an enormous amount of money, and the only way you can do that is with international collaboration and a lot of funding from governments. The current state of the world is such that international collaboration is very hard to come by. Maybe 10, 20 years ago, there was a lot of hope that there would be international collaboration, including China, the US, the European Union, and so on. Nowadays, that looks a lot less probable. And I think without progress in building larger accelerator machines, it's going to be very challenging to make a lot of new discoveries theoretically, because what we theorists have proven over the past 20 years or more is that we can speculate a lot, and without experimental data, we go off in all kinds of directions that are not correct. And so we really need the experiments to show us what to look for. And in our field, experiments are very hard to come by and very expensive. So that's the challenge.
If you could define physics in a single sentence, what do you like physics? What is physics? What would you say?
I think of physics as the simplest of all the sciences. It's the one in which you can make the most precise statements and make the most precise checks of your theories. The other sciences, chemistry, biology, are much more complicated. It's much harder to make precise mathematical theories, and it's much harder to make precise checks of your theories. And so physics, I think of as the simplest science. That's
and why do you enjoy so much being a physicist?
Just because it's fun.